So the International Space Station, a very unique environment for men and women to work, very unique laboratory operating in microgravity around the clock. And it can be a little stressful sometimes, and we always have to be mindful of the crew's health to make sure they're operating at peak efficiency. And there's one study that's been taking place over the past couple of years and is getting some special focus during the one-year mission with Scott Kelly and Mikhail Kornienko called the Reaction Self-Test. And to learn a little bit more about it today, I'm joined by Dr. David Dinges, who's the chief of the unit for the experimental psychiatry at the Perelman School of Medicine at the University of Pennsylvania. So first off, doctor, thank you so much for joining me today. And if you could start us off, what is it about living on the International Space Station that makes crews susceptible to things like, fatigue or other stress indicators?
So thanks for having me. First of all, we wanted to document, are they fatigued? And the reaction self-test contains a series of questions and a very brief vigilance test. And we gathered about 2,500 responses from astronauts, 24 astronauts over 6-month missions. And there's no question they're reporting more fatigue and more physical fatigue and mental fatigue. They're also, though, reporting higher workload than we see people rating in the analogs on Earth. So one possible factor could be increased workload, but they're also showing signs of reduced sleep time and some of them poor sleep quality. And as a result, we think there's a combination of factors, including potentially physical factors, because they show increased responses of physical exhaustion. And that's unusual given that they're in microgravity.
So you've gotten a lot of data that are showing signs of fatigue. What are some of the effects that this increase in fatigue can have on these crew members while they're up in space?
Well, this is really the reason for getting this data set, to understand what we sometimes refer to as behavioral health or neurobehavioral health, sort of brain and behavior. Are there changes ongoing in the space environment, and could some of those be mitigated by operational interventions versus health interventions? And it looks very much now like one big finding is there's large differential vulnerability, meaning some astronauts cope much more effectively with these factors than others. Others report being more impacted by them, more exhausted, struggling more to function. Most of them can hold their performance up very high. And this test is annoying to do, and we had them do it at least twice a day. So they were really challenged to keep doing it. It only takes 5 minutes, but it's not terribly interesting. You have to focus your attention. It's made to be hard to do with the demand on attention. And in doing that, we find that some of them can do that rock solid and stay right with it, and others have much more difficulty, and they also are the ones reporting more difficulty with exhaustion.
Okay, so walk me through a little bit. So what is the test? You said it can be a little bit difficult for these crew members. How exactly are you guys gathering this data from all of these crews on board the station?
Well, the test is all of this, and the Q&A on the test, everything on it is in software on the support computers on the station. So an astronaut can open up any support computer and take the test. The performance test is 3 minutes. It's called the psychomotor vigilance test. It's actually the brief version, and it's actually astonishingly simple. You simply watch the screen of the computer, and when a light comes on, you press the key, the space bar that your finger's on, and the light is actually a millisecond counter, thousandths of a second going by, and it stops and tells you how fast you were. Then it goes out and randomly comes back on again. And you do that for 3 minutes. It's unaffected by educational background and by learning. It is well validated scientifically on Earth to be extremely sensitive to fatigue level. And so what we're doing is using this objective probe to get a sense of how much astronauts are affected by the subjective fatigue they're reporting in spaceflight.
So earlier you had mentioned that you had compared this to actually analogs or kind of situations down here on the ground that mimic the same environment. What are some of the other places or situations that you've been collecting data from to compare against the International Space Station?
Well, we've been particularly fortunate. First of all, the test was developed on astronauts. Since they're such high performers, we tend to develop our tests on astronauts on Earth. So Nemo, for example, was a location under the ocean. Then we went on to look at astronauts in the high desert, in a number of other locations. But we also did the Russian 520-day simulated mission and got 1,000 responses out of those crews on this test. And so we have a lot of data to compare, and we've done a lot of those comparisons.
Okay. Well, I mean, it's a fascinating study, and you're going to be getting some special data from these one-year crew members on board the International Space Station. So, again, Dr. David Dinges from the University of Pennsylvania talking to us about the reaction self-test ongoing. Doctor, thank you so much for joining me today. Really exciting experiment. Really appreciate your time today. Thank you.
Thanks for having me.